So to start off our next unit, we're going to go through what are relations and then also something that's more specific, which are functions. And that's something we're going to be working with a ton throughout the semester. So we're going to cover three main things. We're going to talk about first, what is a relation? And then how do I classify a function, which is a specific type of relation? Then we're going to go through the vertical line test, which is going to help us identify if something is a function or not. And then how do I talk about finding what's known as the domain? And that's going to be one of our most important things we do throughout the semester. So first and foremost, we're going to begin with our main kind of topic, which is a relation. And really think of it just like a relationship. It's some kind of connection between things. So a relation, the best way you can think about it is a correspondence between two sets. So you can think of it like a set of ordered pairs. No matter what picture is given to you, whether it's a table, whether it's kind of a flow chart, whether it's a graph, you can always create a set of ordered pairs with x values and their corresponding y values. So those input values are what we call the domain, and typically they're going to be x values. Then based on your input, you're going to get an output, which is typically a y value, and that output is called the range. So for a relation, there doesn't have to be any kind of criteria to distinct, like there has to be so many x values or so many y values. It's just the connection. A function is going to be something more specific where your input value has to have exactly one output. So I can't have an x value that corresponds to two different output values. That's going to be a relation, but it's not going to be a function. And then regardless whether we're working with a relation or a function, finding domain and range is something we want to do. So that's going to be our first thing. We want to go through it and we want to determine if this relation is a function, and regardless, we're going to find the domain and range. So for our very first problem, we have a chart and we have a bunch of x values, which again are the input, and then they have corresponding y values. So this point here has an x value of 0, a y value of 1. And the next one, you'd be able to make the coordinate pair 2, 2. This would be 0, 3, and this would be 4, 4. Now looking at this, you can go ahead and graph those, you can plot them, but we want to make sure that the input only has one output. So I have got no problem here with my input being 2, I have a single output. Same thing with 4, that being my input has a single output. But when I look at 0, it has a corresponding y value of 1, and then it also has a corresponding y value of 3. So the input 0 has two different outputs. So although it's a relation, this is not a function because I don't satisfy that unique input or that input having a unique output. Now, regardless, I can still find my set of input values and my set of output values. For my input, I just want to list the values. So we have 0, 2, and 4. I don't need to include 0 twice because it's already included once. And the thing I want to make sure I do is I want to put these braces around those values because I want to say my domain is the set of these values. If I just list out 0, 2, 4, it's not really signifying the set of input values. And then we're going to do the same thing for the range. We're going to start off by saying it's a set, and the y values we take on are 1, 2, 3, and 4. So you always want to be as precise as you possibly can. Don't include more values than you need. So a common mistake we might see is we've dealt with interval notation. Some people might write this as 1 to 4, but I don't want to do that because I don't actually include all of the values between 1 and 4. So when it's just a list, I've got to be precise. Now in our next example in part B, we're given basically a mapping. So the way we kind of read this is x is my input, and we have this arrow coming off of it to 4. So it means -3 is going to correspond with 4. 0 corresponds with 7, and 7 corresponds with 4. So if I consider my input values of -3, 0, and 7, I only have a single arrow leaving them, which is good. So that input only corresponds to one of these output values. So each input has a single output. So because of that, this is a function. And then again, we can find our domain and range. Typically, we just use a D and an R to signify those. Our input values are -3, 0, and 7. And these are the set of values. And our range is 4 and 7 only. So even though 4, again, has 2 inputs that correspond to it, I only include it once because it's a single number. All right. Now let's try some graphs. Let's try to figure out what the domain and range are and whether they're a function or not. So if we start with this first one, our input values are, again, these x values. The output is y. And so if you consider a single input, it corresponds to a single output. So regardless of the x value we pick, though, there is one y value that corresponds to it. So this is a function. Okay. Now for the domain and range, because it is a function that is continuing on forever, so typically our book will use arrows at the end to say it goes on. We're going to be able to input anything we want, and because it's continuing up and down forever, our output is anything we want. So our domain is going to be all real numbers, which you can think of as the interval from -infinity to infinity. So it's the real number line. And our range is exactly the same thing. We're going to take on every single y value. So again, it's all real numbers. Okay. Now for our next one, we have a circle. And so I want to think of this the same way. If I consider my x value at positive, what is that, like 0.5? It has a y value up here that corresponds to it, and also a y value down here that corresponds to it. When your input is 0, same thing. You have one point here that's 0, 2. But then you also have another point down here, which is 0, -2. So these x values have 2 corresponding y values. So because of that, this is not a function. Okay. So we can still find the domain and range though. And for this circle, the very first x value we have is -2. And then I can include all those values up to +2. So that is exactly our domain, and we can equal -2 and 2. Our range is going to be exactly the same thing. The first y value we have is -2, and we can hit every single y value up to +2. So the range is the same. Okay. So this concept is actually what's known as our vertical line test. So if I go back to this picture, when I draw a vertical line, it hits the graph in multiple spots. Where in this example, every time I draw a vertical line, it hits in a single spot. So remember, a vertical line just corresponds to x being a certain number. So what the vertical line test tells us is if every vertical line you draw intersects the graph in no more than one point, then that relation is a function. So just like the last example, if we draw a vertical line for this first one, hits in a single spot, hits in a single spot, hits in a single spot. No matter where we draw a vertical line, it hits in one spot. So this is going to represent a function. Same thing for the second example. We draw a vertical line, hits in one spot. Draw a vertical line, single spot. Vertical line again, single spot. Every single time you draw a vertical line, it'll be a single spot where it hits. So this one is also a function. But for this last example, even though over here, I don't hit the graph, so I'm not breaking the vertical line test. When I draw a vertical line on this side, I hit in 2 spots. So this x value corresponds to 2 different y values. So this one is not a function. Okay. So this is going to be kind of our quick way to test whether something is a function or not, especially knowing its basic shape. So one of our later sections, we're going to go through kind of the main type of functions we have and what their graph looks like. And then based on that, we're going to be able to identify whether it's a function or not pretty quickly through this test. Okay. So the very last thing we want to do, because we're going to be working with functions so frequently, is we got to talk about when do I know what values are going to make sense for that function, and how do I figure out what the domain of an expression, relation, function is going to be. And so there's 2 main things that we want to keep in mind. The very first one is that you never, ever, ever want to divide by 0. So if you have a number that's going to cause 0 in the denominator, you need to exclude it. The second thing, we're dealing with real numbers here, so I need to make sure my output makes sense. We can't take the square root of a negative number. Square root of -1 is going to give us something imaginary. Square root of -4, same thing. None of those are going to make sense. So we also need to exclude any values that give us a negative number under an even root. So it works for square roots, 4th roots, 6th roots, 8th roots. They all have exactly the same type of domain. For odd roots like cube roots and 5th roots, there are no problems there. You can absolutely have negatives underneath. So we just have a couple more examples and we want to go through and we just want to find the domain. The range isn't typically as important for us. So in certain instances, yes, we can figure out what it is, but finding the domain is absolutely something we need to be good at. So we're going to start with the expression y equals -6x. And so if you think back to our first unit, that's really just a line. So we can graph those, we know how to deal with this, but just looking at the expression, because the variable is -6 times x, there's nothing I'm going to plug in that's going to make me divide by 0. I have no radicals, there's no square roots, there's no 4th roots. There's no issues with this expression in any way, shape, or form. So because there are no problematic values, there is nothing that will make us divide by 0. We really get to plug in whatever we want. So just like our last example, our domain is really everything. It is all real numbers. So in interval notation, that would be from -infinity to infinity. And again, that just means all real numbers are good, because nothing will pose an issue. I won't have one of those 2 problematic cases. Okay. Now for our next one, we do run into a bit of an issue because we have this variable in the denominator. So there are possibilities where I might plug in a number that will cause me to divide by 0. And so the way we're going to figure that out is we're going to go ahead and set that denominator equal to 0, because this is our problem. And if we go through and solve that by adding 4 to both sides, x equals 4 is going to be an issue. So if I were to plug this in back up here, The y value corresponding to it would be 2 over 4 minus 4, which is 2 divided by 0. And this is a problem. I cannot do this. So immediately, this is our problematic value. So really, that is the number we need to exclude. So our domain, the only restriction we have is that x cannot equal 4. But we do want to write this in interval notation. So let's go ahead and draw a little picture to help us out. 4 is the only problem. So we have a circle here, but I cannot fill it in. But every other value is perfectly fine. So we can continue this way forever. We can continue that way forever as well. So the way I would write this first interval is we start at negative infinity, can't equal it. We go all the way up to 4, also cannot equal that. The second interval is it starts at 4 and then continues to the right forever to infinity. The way we say I can pick any number from either one of these sets is we use what's called the union symbol. And all you can think of this as is the word or. So I can pick anything from the first set or from the second set. So this is how we write our domain in interval notation. So I got one more left. We've got a square root. And again, I want to make sure that the thing under the square root is not a negative number. So the way you're going to deal with these is you need whatever expression you have underneath the radical to be greater than or equal to 0. So I just want to solve this inequality just like we did in our last unit. So we want to isolate our x value. So we'll go ahead and subtract 9 from both sides. And that gives us 2x is greater than or equal to 9. And then we need to divide by 2. And that gives us x is greater than or equal to negative 9/2. And if you want to see that's a relatively nice number, it is negative 4.5. Okay. So just pay attention in your homework what it actually asks you to input it as. It might say as an integer, it might say as a decimal, that's fine. Okay. But negative 9/2 is our starting point, and then I can pick all x values that are greater than it, so we can include everything to the right. So our domain in interval notation is we start at negative 9/2. We can include it so it gets a bracket, and then we can continue to the right forever to positive infinity.